Hey, greetings and welcome, internet friends. Mr. Waddy here, and going over some more systems of three variables and equations. So today we're going to be going over some of the homework, some problems about elimination method, as well as substitution method I think I've gotten here. So here for elimination method, looking at all three, I've already got my x's and y's and z's and equal signs and constants lined up in columns. So far, at least this textbook, that's always been the case. Maybe tomorrow when we do some word problems, we'll have to rearrange them on our own. But here, let's find the least common multiple between the x's coefficients. So between 3, 6, and 2, 6 is the smallest number that they all go into. 1, 2, and 1 is 2, and 2, 4, and 3 is 12. And so I'm going to go for opposite y's here. And looks like I'll multiply. Let's see. This one's already a negative 2y. This is negative. This is negative. So I'm going to have to get at least one positive y, positive 2y. So I'm going to multiply this negative 2a. And tell you what, I'll do 2c, plain old 2c. So negative 2 times a, I'd get negative 6x, positive 2y, minus 4z, and negative 2 times 4 is negative 8. And then the bottom row, multiplying by 2 in order to get the 2y's there. This equation, by the way, already had a negative 2y. So 2 times 2x is 4x, minus 2y plus 6z equals 2 times 10 is 20. Nice. And now I'm going to use the elimination method, right? Where I add some of these together and eliminate some of the variables. So let's try. We'll do negative 2a plus bravo. And then we'll do negative 2a plus 2c. Boom. And so negative 2a plus b, I've got, I'm going to have double elimination here. That's unusual. 6x and negative 6x both cancel out. Negative 2y and 2y both cancel out. 4z and negative 4z, triple elimination, both cancel out. All right, and what am I combining? A and B. Wait a minute. Wait a minute. Negative 2a and b. Here, right? Boom, boom. All right, that's how easy it can be to get lost. And I get 0 equals 0. So that tells me there's going to be infinitely many solutions. Aha! And I don't think I even have to do this one now. But we should try to find an expression for all of these. Well, let's see what happens if I eliminate these. So negative 2a plus 2c. So I'd get negative 2x. I'd have plus 2z equals 12 when I combine those. So if I want to write everything in terms of x's, I could solve this for z to rewrite that in as an expression in terms of x. So add 2x to both sides. And I've got 2z equals 2x plus 12. And then divide everybody by 2. And let's scroll down a tad there. And so an expression for z will be x plus 6. And so of my ordered triple, there are infinitely many answers, and the z value must be of the form x plus 6. So whatever x is, z has to be 6 more than it. And now that I know, this is something I could do. Well, I've got to solve for y in terms of x. And so I'm going to plug this in here and solve this equation for y. So let's see what I got. So 3x minus y plus 2, and instead of z, I'll write that expression right here. And so now if I solve this equation for y, I'll get an expression that describes all of the y answers for this problem. So let's see, 2 times x is 2x, 2 times 6 is 12, equals 4. So notice the importance of those parentheses so that I'd remember to distribute. 3x and 2x is 4x minus y plus 12 equals 4. And then tell you what, let's move two things at once. This is algebra 2 after all. Let's double move things. So I'll subtract 4x and 12 from both sides. And I'd get the opposite of y equals negative 4x, and 4 minus 12 is negative 8. And if that's what the opposite of y equals, then the positive version of y is positive 4x plus 8. Good, good, good. And so here is the infinitely many answers are of this form. Okay, so because all of my variables had eliminated at one point and I was left with a true statement, I knew I had infinitely many solutions that made all of these equations true. But it doesn't mean everything works. It's just that there are infinitely many things that do work. And that's a little bit of an odd idea, I suppose. But yeah, there we go. And so that's a way I could describe what those things are. So whenever x is 2, I could plug in 2 for those and figure out another solution. Whenever x is 7, I'd plug in 7 for the x's and find another solution. Here's question 19. And so this one's asking for the substitution method. And so substitution, what we do is we solve one of the equations for one of their variables and plug it in to plug that expression in to the other equations, in this case, plural, because there's 3. And so looking at all 9 of these variables and their coefficients, the easiest one to solve for is the first equation's y, because it has a positive 1 coefficient. A negative coefficient, negative 1 coefficient, is equally easy to work with. And so let's do that. So negative 2x plus y plus 6z equals 1. And let's get y by itself. So I'll add 2x to both sides. I'll subtract 6z from both sides. And I'll get the expression. This is called the revised equation. Y equals 2x minus 6z plus 1. Right? Yeah, none of these three things were like terms. And so this is what y is equal to. And notice, if I take this, if this is truly equal to y, that means I can replace y anytime I see it. And if I replace the y here and here, by substituting in for both y's, I'm getting rid of y and getting more x's and z's, which is similar to when I eliminated, is it not? And so I guess I'll keep working this way. So 3x plus 2 times y is now this entire thing, plus 5z equals 16. And I guess I'll work with this before otherwise it'll just get in the way if I write the other part right now. And so let's simplify this. So 3x plus 4x minus 12z plus 2 plus 5z equals 16. So I distributed this, whoop, 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 and combined some like terms. I got 7x. The z's can combine to be negative 7z. And tell you what, I'll simultaneously just subtract 2 from both sides. And so I get equals 14. Boom. And so there's one equation with no y's. What's the other equation that I was plugging in for? Right here. And so this is, by the way, a different setup. 7x plus 3y, and I'm going to replace y with that purple expression here, minus 4z equals 11. And let's try to use our start wearing purple. Here we go. And so let's simplify, and I'll have another equation with 2 variables, the same 2 variables as this one. So good stuff. Plus 6x minus 18z plus 3 minus 4z equals 11. and combine those like terms. Looks like 13x minus 22z, subtract 3, both sides, and I get equals 8. And so I'm going to name this, just these are the two that I'm working with, by the way. I'm going to call this equation D and this equation E, just so I know what I'm working with. And looking at these two equations, and tell you what, I could rewrite D down here just to make things, I don't know, sometimes when they're side by side, it's easier to see what's going on. Because if I keep bouncing my eyes between these rows, I might look at the wrong row, and that wouldn't be good. All right, so here's the two equations I'm trying to solve. And now this is like an Algebra 1, Chapter 5 problem. And I'd rather not solve... Well, okay, ooh. Now, the top equation I definitely don't want to solve using substitution, because look at, this has a 13 in front of it, this has a negative 22 in front of it. To get rid of that multiplication, I'd have to divide. Dividing creates fractions. However, the bottom equation, substitution isn't bad. And I'm going to use it. I'm going to use it. Because, notice, the coefficient here is 7. This is 7, and this is a multiple of 7. So if I do have to divide by 7 on both sides, it's going to cancel out, and I won't have any fractions. So it's not terrible. Although I could have gone the elimination method and tried to figure out what 7 times 13 is and what 7 times 22 is and least common multiple and all that. But in this case, substitution is the easier way. And so I'm going to tell you what, I'll highlight it in blue. I'm going to solve for x first. Hey, quiet over there, Waddy boys. So let's see, 7x equals 7z plus 14. And now div 7, div 7, div 7. And so x equals z plus 2. And you might be like, I still don't have an answer, and you're correct. But we do have an expression that is equivalent to x. And so what can I do? I'm going to plug this in here and solve for z. And so 13 times what is formerly referred to as x minus 22z equals 18. And so I've got z plus 2. All right. And so notice all of this work. Now I finally have a single equation and a single kind of variable. And so 13z plus 26 minus 22z equals 8. Combine some like terms. 13 minus 22. I feel like that's negative 9. Negative 9z. And tell you what, we'll simultaneously... okay, fine, I won't. I'll write a separate line of work here for you. Subtract 26 from both sides. Negative 9z equals negative 18. And aha, now I'm solving. And I get z equals positive 2. Careful of that double negative. And so now that I know what z equals, let's trace this back up through. If I plug this in here, I'll solve for x. And so x equals 2. Oh, okay. All right. Z plus 2. All right, what color am I here? And z is 2, but my 2's and z's sometimes look the same. And so I get x equals 4. And so now I know what x equals. And so now that I know what x and z are equal to, I could plug them in for... No, I can't plug them in there, because then I'd end up just getting a true statement. I need to find y. Oh, look at this. Here's already solved for y. I'm going to break the fourth wall. I'm going to zoom out here beyond space and time. And I'm going to, all the way here, plug in for z and plug in for x. And I'd have what? Y equals, I think I have enough space here. Yeah, these problems take a bit of space. By the way, you're welcome. I removed some problems from the homework this morning. I was like, these problems take so long. I'm going to get rid of me some problems. So 2x minus 6. I'm writing mega large once I zoom back in here now. All right. Rip. Rip. That's so weird. And so what did we have for x? We had x, I thought z was equal to 2. I remember that. And x was equal to 4. And so notice, now doing the double subs, I can have 8 minus 12 plus 1. There's no more variables, just plain old y. And so 8 minus 12 is negative 4 plus 1. Y equals negative 3. And so final answer, x was the 4, y was the negative 3, and z was the 2. And so this only had a single solution that made all 3 equations true simultaneously. All right, and that's why there's only one in this case. All right, there are infinitely many that would make the first true, or the second true, or the third. This is the only one that makes them all true at the same time. Now let's see, did I have one more? I did have one more, but this problem's easier. Notice equation A, I'll call it, is already solved for x. Oh, boom. So, hey, we're well on our way. And since that's solved for x, I could now substitute it in here and solve for y. And so x plus y equals negative 6. I could plug it in here too, but I noticed that this equation only had 2 variables. And so it'd be even easier to solve. And so let's see. So subtract 4 from both sides. I happen to get y equals to negative 10. And so while this problem looked scarier to begin with, because it didn't have everything lined up in columns that I like to have as far as my solving by elimination method, it ended up being a little bit easier. And so I'm going to plug in here. I'll plug in 4 for x. I'll plug in negative 10 for y. And tell you what, I'll do that right over here. So 4 times x minus 3 times y plus 2z equals 26. Substitute 4 and negative 10. And I get 16 plus 30. Careful of that double negative. Plus 2z equals 26. Those combine to be, 46. All right, and my 2's and c's look even more similar over time as they're next to each other. That's weird. And what's this? Negative. Wait. Whoa! Look what I did. I had a typo. Right here. That's a 26. Oh, that looks worse. That looks worse. Oh dear. Watch this. I'm gonna just. All right. 26 minus 46 is negative 20. And now divide both sides by 2. And I get z equals negative 10. There you are. And so, boom, got 'em. There's your answer. So solving by elimination or substitution, sometimes one is easier than the other. They both work all the time. Just depends on how much work it becomes. In this problem, I would always use substitution if I had a choice, because one of these variables was already solved for. It looked much easier. All right, well, thanks for watching, Internet friends. Have a great day. Bye-bye.